you all in this two-day workshop on research and career opportunities in artificial intelligence organized by Department of Physics, MIT School of Applied Sciences. This two-day event brings together cutting-edge insights to AI, general AI, and neuroplasticity, and we are privileged to have such an esteemed gathering. To formally open the workshop and extend a warm welcome to our distinguished speaker, Dr. Krishnaraj Rathinam, I would first like to invite our head of the institution, Professor Seema R. Pathak, whose guidance and vision continue to inspire excellence across all academic and research endeavors, to deliver the welcome address.
Thank you, Dr. Anna, and very good afternoon to esteemed faculty members, dear students, distinguished guest, Mr. Dr. Krish Rath. It gives me immense pleasure to welcome you all on this two-day workshop on research and career opportunities in artificial intelligence organized by Department of Physics, MIT School of Applied Sciences. We know this is era of artificial intelligence. Everybody is rushing behind it. So it is right time to discuss and throw some light on this topic so that our faculties along with their students can be benefited and they can utilize their knowledge for their career growth and for their research growth as well. So we are honored, sir. You are we know that you are a renowned, internationally renowned expert in this from NASA and NSF, and your expertise will definitely enrich our understanding and for AI and inspire our, as I said earlier, that inspire us to explore new avenues, of course, for research and for collaboration further, because in MIT lots of emphasis is there on collaboration to have co-PIs from a very good institutions of repute, so that we can have a good exchange of ideas and knowledge sharing, right? So I encourage each of my faculty members to participate and ask questions and take full advantage of this session. And definitely I will be also asking some questions, because I'm very much interested in integrating AI in chemistry right now, so that my students can be benefited for that. And together, let us continue to strengthen Amity University Haryana's commitment to innovation and quality education, global engagement. Right. So I just wanted to emphasize that at Amity, our chancellor's vision, our founders' visions are immensely, deeply rooted for collaboration. For they motivate us to collaborate, to do very good research, to have ideas patented, and to have some TRL level 1, 2 product prototypes sort of thing. So here definitely, sir, you are given us time, and definitely we say that we will do full justice of knowledge what we receive from you, and will definitely work harder in coming days in your guidance for this particular topic. Thank you so much. So I request you to start your session, and I thanks Dr. Ayana from core of my heart for making such a knowledgeable person on this panel on a very short notice, and making you available, sir, for this time, because I know that it is USA and there is a good gap of time. So what is time at your place?
Hello?
You are muted, sir. You are muted.
Hello?
Sorry, yeah, it's 4 a.m. 4 a.m.
Yeah.
here.
4 a.m. So it is,
I would like to invite Professor Preeti Thakur, head of the department.
Sorry, yeah. I request Dr. Preeti Thakur
leadership and dedication have been instrumental in organizing this workshop, to give a brief introduction to the eminent speaker.
So thank you, Dr. Ayana, and thank you, Krish. So I request Dr. Preeti to say a few words to encourage audience to attend this workshop.
Thank you, Professor Seema. Such a pleasure connecting with you.
Good afternoon, all. I welcome Dr. Krishna Raj Rathinam for this workshop. A brief introduction about Dr. Krishna Raj. Dr. Krishna Raj Rathinam is a lead scientist with Composite and Nano Advanced Manufacturing Biocenter, South Dakota, USA, since 2016. Prior to this, he worked as a scientific officer in NIT Durgapur, a PhD in engineering from Central Electrochemical Research Institute, CSIR Lab, Tamil Nadu. Dr. Ratinam obtained HBX Business Certificate Program from Harvard Business School. A healthcare leader with over 14 years' experience in initiating, directing, and developing healthcare solutions, technology development, Dr. Rathinam has technical expertise in artificial intelligence, models, ML frameworks, cybersecurity, automation, data visualization, natural language processing, digital supply chain, among others. Dr. Rathinam has several publications and patents to his credit. Now, not taking much time, I invite Dr. Rathinam for the workshop.
Well, thank you so much, Dr. Preeti. Such a pleasure connecting with you. And shall I go ahead and share my screen? Diana, shall I go ahead and share my
You
screen?
can share your slides and please start.
Okay.
Yeah,
Okay.
thank you.
Wonderful. So can you see my screen? I'm not sure. Okay, perfect. Okay, my screen. Let me do that. Hope you can see my screen.
Yeah, your slide is visible.
Okay, perfect.
Okay.
Wonderful. It's such a pleasure connecting with you all. Thank you so much for taking your time and efforts. I'm so grateful to Ayana for taking this initiative. She has been working so hard for the past few months. And I also want to thank Professor Seema and Professor Preeti for taking this initiative. It's such a pleasure and it's such an honor to connecting with you all. So today we are going to talk more about the opportunities in AI. So let's cover some basics of AI and then we'll go what are all the higher education opportunities in AI. I assume most of you are students from BSc or MSc students in physics or chemical sciences, and or you may be a graduate student doing PhD or you may be a postdoc. So I'm focusing on two different things. The first part we will be focusing on basics. So before I'll come to this, yeah. So first part we will cover all the basics of AI. What is AI? What is Gen AI? And what is agentic AI? I'll give you some basic techniques that can help you to write a research article, that can help you write a proposal, or if you are a postdoc, so then we will be focusing more on higher education. If you are a master's student or if you are a PhD student, then I'll give you some opportunities like, okay, what are all the higher education opportunities or career opportunities in tech giants? So we'll focus on those things. So two things. One is basics of AI, Gen AI, and agentic AI. And the second one is what are the career and higher education opportunities. Will not take more time. I'll try to do it in 45 minutes or 1 hour, and I'll give the remaining 1 hour for you to ask questions. Right? So yeah, let me give you a quick glimpse of who I am. So my name is Chris. I'm a healthcare consultant based in Washington, D.C. So we help. So what we do at GoTo Partner, we help pharmaceutical companies and med device companies provide AI training and help them to develop technologies like in product development, process improvement, manufacturing, supply chain, and quality. So we also help students in the areas like industry-based AI, Gen AI training, and help them get opportunities in tech giants or going into top global universities like Harvard, Princeton, or Stanford. So why this workshop? So always we are providing this AI awareness workshop. So it helps the students, it's booming so rapidly. AI is booming so rapidly, and students and parents ask, oh, should students use AI? When and how should they use AI? So what are all the skills they should get in AI to be successful, right? So those are some questions. So we help them focus on these areas. So as I said, two areas. You don't have to have any basics. So let's focus into what is AI, what is generative AI, and what is agentic AI, and how it's important in science or technology. And number two, let's discuss some use cases. We'll brainstorm some use cases. You can bring your own use cases, and we'll try to design some problems, design some experiments. And the third one is, what are the core skills you need as science graduate? You may be a BSc student or a master's student, or you may be a PhD student or a postdoc student. You want to do higher education in US or in any other country or even in India, or you want to go to tech giants like, Meta, you want to go to Google, you want to go to Microsoft, you want to go to Amazon. So how can you go into those, tech giants with the skills at the interface of science, physics, and chemistry and artificial intelligence? So these are some of the areas we will focus on. So before I go in, I'll give you what is the scope of AI. I'll share a small video that gives you a scope of AI. What is the scope of AI? Hope you can see my video. Can you hear the audio from my video? Is it audible? Okay, I'm sharing a video. I hope you can see it. Is it? Okay. Aina, can you see this video?
Yes, it is okay. Thank you.
Okay, perfect, perfect. So this will give you a scope of what artificial intelligence and how it is. So now let me go to the slide. So we'll start with artificial intelligence. Hope you can see my slide. So what is artificial intelligence? So making machines to adapt, reason, and provide solution. You're just going to making the machine to behave like humans, right? Intelligently. There are three different types. One is artificial narrow intelligence. You do a singular task. If your AI solution can perform a singular task, for example, there is Siri. You ask Siri, Siri, what is the time? How long does it take to go from Haryana to Delhi? Right? You ask some basic question. It does only one simple task. It retrieves those information and give it to you. So that's what is artificial narrow intelligence. Artificial general intelligence. It is just like mimic. If it can mimic human intelligence, we call it artificial general intelligence. And the third one is artificial super intelligence. If it can surpass human intelligence, right? Like just like a co-pilot. It's right. It can surpass human intelligence. Then we call it artificial super intelligence. So we have three different categories. So artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So artificial, let me, yeah. So the point is, so these are, it is not something new, right? You're using it. Okay, just 1 minute. Okay, it is not something new. You are using it on a daily. Okay. It is not something new. You're using it on a day-to-day basis, right? You're using Google Map and you have all the AI features in all these things. Google Map, you are using YouTube, Netflix, you have it suggests videos, and you're using some voice assistants like Alexa, Siri. You're using, in your iPhones, you use, AI to unlock your face, right? So your phones, and then you do online shopping, right? Amazon or I don't know, Flipkart or Snapdeal. So those are things. Okay, so what is the difference between artificial intelligence, machine learning, and deep learning? Yeah, these terms are even often used interchangeably, but it's not right. So artificial intelligence is a broad domain, basically. So if it's mimicking human intelligence, you solve any kind of problem, AI-based, any kind of different classification, regression, or forecasting problem, we call it artificial intelligence, which we will be talking about in the upcoming slides. The next one is machine learning. Machine learning is a subset of artificial intelligence where you build correlation between dependent and independent variables, right? The third one is deep learning. Deep learning is again a subset of machine learning which use neural networks, right? It can solve complex problems like speech recognition or image understanding. If you imagine you have several factors and they have very complex correlations, then we use deep learning. Okay, we'll be talking about these in the upcoming slides. So there are three terminologies you should know. One is artificial intelligence, number two is machine learning, and the third one is deep learning. Now I'm going to this one. So why AI matters? AI is everywhere. As we shared in the video, it's not something new. It is everywhere. Whatever the industry you are in, whatever the discipline you are in, whether you're doing physics, chemistry, biology, math, you can't ignore it. Don't say that, oh, I'm not a computer science student. It is like a lingua franca. Everyone should know artificial intelligence, right? That's the situation. So the thing is everywhere. So you try to learn as much as you can. The second one is whether you're in medicine, engineering, law. So your job opportunities are going to be really great if you are having those skill sets. And always, always it helps you to understand technology and develop innovative technologies. So if you are a scientist, you want to develop cutting edge technologies, always AI will be really helpful. So different professions, it's widely used in different profession. Doctors use it, civil engineers are using for predicting structural risk, electrical engineers are using it to design smart grids, lawyers or attorneys, they are using it for reviewing contracts, and drivers, pilots are using it for navigation, accountants, sales professionals. So whatever the field you are in, AI is being used. Okay, so this is very important. So you're a graduate student, you're a master's student, you want to write a research article, you want to do some research, or if you are a PhD student, you want to develop some AI based research work, or you want to write a proposal. This is more important. So three things you should understand. One is ML. When you have ML, it can solve three different kinds of problems. One is classification problem. Second one is regression problem. Third one is forecasting problem. So what is classification problem? You're predicting the classification, your category of this group, right? So for example, I'm showing you a pen, right? So what you say is, oh, this is a pen, right? It is a pen, or so if I ask, is it a pen? Or I'm going to give you something else. Okay, I'm giving you paper. So you're going to find, so is it a pen or a paper? If you ask, you want to develop a model that can find, oh, this is not paper, this is a pen. So if it find, it takes some features, right? It help to write. Okay, does it have 4 dimensions, right? Sorry, 4 sides. So it just takes some of these features and then it makes those predictions. So you're understanding the terminology. So if it helps you to categorize or group, then it's a classification problem, right? You can ask is it a cat or a dog? You can ask those questions. Or else you can say whether I should do this experiment, or whether I should do an XRD or whether I should do an NMR. right? So you can do those kind of questions. So if you're asking the model to make a, make a classification, then that's called a classification problem. So how does the model does this classification? What it does is it takes different features into consideration and makes those decisions. So that's what you design when you design your experiment. What are the feature you should say? For example, you are synthesizing a material and you can do an UV spectroscopy or FTIR spectroscopy. Now, what is the criteria that you will use to decide whether you should do a UV spectroscopy or FTIR, right? A Fourier transform infrared spectroscopy. So that's a classification. So you know what is a feature and what is a classification. So you can build models. Now let's go to the regression. So predicting it is a correlation between independent and dependent variables. For example, an output depends on several independent factors, right? Every output depends on several independent factors. You are developing a chemical reaction or you're synthesizing a material, so you have different factors, right? What is the composition of the of those of the compound or the material you are synthesizing? That's number one. And what is the conditions, what is the temperature you provide, or what are all the synthesis conditions you provide? So those are all different criteria. So you build different dependent variables, and based on the dependent variables, you get an outcome. So that is what is called it is a regression. So if you are building a correlation between independent versus independent variable, then we call it regression. What is forecasting? Based on the predicting the future values, both based on the historical trends. For example, you want to know how much semiconductors will be manufactured in India in 2027. So what do, you take the record of semiconductors produced in the past 100 years and you make a prediction of what will happen in the future. Right? So now you got an idea. So you can design 3 different kinds of problem. The first one is classification, where you are grouping this. You want your output is going to be, okay, which category does this belong to? So if you categorize it, then we call it classification. If you are building a correlation between independent and dependent variable, we call it regression. And if you are given with a historical information and you want to predict something in the future, then you can do forecasting. Does it make sense? So if you are asked what is artificial intelligence, then you just say these 3 words. Okay, it can solve 3 problems. It can do either classification, regression, or forecasting. Right? Or if you're asked, okay, what kind of problem are you doing for your PhD work or for your research article? You say, I'm working on a classification problem, regression problem, or forecasting problem. Is that making sense? I'm giving you some examples. Like classification is identifying the cell type. For example, you take a microscopic image and you say, is it an animal cell or is it what kind of cancer type is it? Right? So if you're classifying, then it's a identification. It's a classification problem. You're classifying the material. You have a material, you're doing some different kinds of analysis and you want to classify the material. Then, okay, detecting the chemical compounds. So these are all classification. You're grouping it. Right? So your output is not going to be a number, it is going to be a group or it's going to be a type, right? If it's a regression, you're building a correlation between n number of independent variables and one or n number of independent variables. So you're building a correlation. So that is what is a regression. And the other one is, okay, the forecasting. You have historical information and you're predicting the future, then it's going to be forecasting. So I'll go to the next one. So now when we are talking about a regression, we were talking 2 different things. One is independent variable and the other one is dependent variable, right? So what is independent variable and what is a dependent variable? So the independent variables are the factors that influence the outcome, whereas dependent variable is the outcome. So you're building a correlation between independent variables versus dependent variables. So I have some examples here. Hardness or strength. So it can depend on, of the material, can depend on different independent variables like temperature, cooling rate, composition, pressure. So I'm giving you some examples. All these factors can determine the hardness of the material. Some of these can influence significantly, that's a positive correlation. Some of these may not significantly correlate with these outcomes, right? So some of them may positively correlate, some of them may negatively correlate, some of them may not correlate at all. So you have to understand these. Number one, when you want to identify what is the outcome, and number two, identify the list of factors that contribute to the outcome. Some of these factors may significantly contribute to the outcome, some of them may not significantly contribute to the outcome, some of them may positively correlate to the outcome, some of them may negatively correlate to the outcome, some of them may not correlate to the outcome. Is that making sense? So if you understand this is what is regression. So again, I'm going to repeat it again. So you take any example for your project. Okay. So you identify a dependent variable. So what you do, and then the second step is you're going to identify different independent variables that contribute to the outcome. And then you can see, okay, is it going to significantly contribute to the outcome? Some of these factors, for example, you're coming to college, right? So you have your cousin's marriage. You're not going to attend the college, right? You're not going to come to school, right? So the point is, so that's a good correlation, right? That's a negative correlation. If there is your cousin's marriage, you're not going to attend your university, your classes, right? So that's a negative correlation. Now you have an exam, but you will be attending your university. So that's a positive correlation. Is it making sense? So that's and again, how important you have an important exam, you have some event in your college, so you may not attend, but if you have an exam, then you may attend. So that's what is a positive correlation, if it's significant correlation and it's not a significant correlation. So there are some there are some analytical methods which you can use to identify which of these factors contribute to the outcomes. You can identify, you can quantify which of these factors contribute to the outcomes, just using some analytic techniques. So for now, I would encourage you to understand what is an independent variable and what is a dependent variable. So two things, if you want to do a research in AI, two things you should know. Number one, identify which kind of problem you're going to solve. Number two, if you are doing regression, you identify what is the dependent variable you want to measure and what are all the different independent variables. And you should have data for all these things. So imagine you have temperature, cooling rate, alloy composition, and pressure, data for 100 different items, and then you measure hardness. Now you can know, okay, how important is temperature, how a cooling rate influence hardness, how each of these factors contribute to the outcomes. Is it making sense? So that's it. So this is how you design your experiment. So now let's go to generative AI. Now you got some idea about what is artificial intelligence. Now let's go to generative intelligence, right? So you are using on a regular basis, you are using Copilot, you are using ChatGPT. So what do you do? So it can generative AI. What does it do? How is it different from AI? It's completely different in terms of algorithm. It's completely different. It uses naive Bayes, nearest neighbor, neural network, decision tree, and support vector in case of AI. But if you have generative AI, so you use recurrent neural network, reinforced learning, auto encoders, attention mechanism, gated recurrent unit, generative adversarial network, variational auto encoder. So you don't have to learn all those terminologies, right? So I'm just giving you what you have to know, right? So the point is AI. When you have AI, you're using Copilot, ChatGPT, you are using on a regular basis. So they can help you generate text, they can images, music. You can use, for example, if you are using GitHub, then it can help you generate code. Even Copilot can help you. And videos, it can generate videos. You're generating any of these, then we call it a generative AI. So it's different from artificial intelligence. So you use a large language model to write, summarize, translate, or answer your questions, right? You ask some questions and it gives you contextual answers. And generative, okay, so these are all the different kinds of models that we use. And generative adversarial network can help you giving you images or videos, and then anything with image, audios, or videos, and even code. You can write code. If you don't have a coding skills and you want to do vibe coding, there are different things. Even ChatGPT and Copilot can give you code, and GitHub is widely used. GitHub Copilot is widely used to write different kinds of code. So either you do Java or Python, so no worries, right? React, so Angular. So you get all those codes with these kind of tools. So now you know what is artificial intelligence. Generative intelligence is, or generative AI is about generating. It's all about generation. So what does it generate? It generate text, it can generate image, it can generate medias, music, videos, right? So these are all the things. So as of, as a physics graduate or a chemistry graduate, where can you use this? One is you can create, for example, you want to write a SOP, standard operating procedure. You want to write a manual, or you drafted a manual and you wanted to check it, right? So those kind of things you can generate it using generative AI, right? So you can prepare a manual and you can get your manual. For example, in an industry, if they want to write a quality manual, it will be maybe 100 pages or 500 pages. How do they do it manually? Now they can use artificial intelligence to summarize all those information, right? Next one, coming to agentic AI. So agentic AI or autonomous agents, so they can take action, so they can do any task or a series of tasks autonomously without human interference, right? You have multiple steps in a process. For example, you have step 1, step 2, and step 3. Depending on your step 1's output, you'll be doing step 2, and depending on step 2's output, you are doing step 3. Now, artificial agentic AI can do it on its own. So it will decide based on the outcome it will decide what step it should do in for step 2, and based on the output of B, what is the next step it should do, right? So that's what is agentic AI. So it is autonomous agents, autonomous systems that can work on its own without human interference. So it can perform either individual tasks or workflow agents which can perform a series of tasks. So there are different kinds of agents that's there commonly. For example, you have a scheduling assistant. You tell the scheduling agent, I want to go from, from Delhi to, for example, Delhi to Mumbai on specific day. Then it will identify, it will find which is the good flight, and then it can talk to the respective departments, get the information, and it can book the flight for you. So there are multiple steps in the process, but it can do it everything on its own. So that's what is agentic AI. There is multi-agentic AI. Multi-agentic AI, suppose you are in physics or chemistry department and you want to write a NAC report, coordinating with all other departments. You get information from your admissions office. You want to get information from your scholarships office. You want to get information from, some other departments. So what it can do, the agent can talk to the agent in the admissions department and ask, hey, I need all these XYZ information for my NAC report. So it can give you information. So multi-agent. So each of these divisions has one agent, and these agents can talk to each other and retrieve the information and perform the task. So this is what is a multi-agentic AI. So let's take a simple example of how humans do versus agents do. For example, let's take an example for a chemistry or a physics-based experiment, right? You're doing a synthesis. You're getting results. If you get a good result, right, there is a color change. For example, you're synthesizing silver nanoparticles or gold nanoparticles, for example. There is a color change, okay? So what you do, okay, if this is this color, what you do, immediately you go and do a UV spec. And when you do a UV spec, you know what spectra you're supposed to get it. And then you go and do an FTIR spec to see what are the agents that are stabilizing agents that is there. And then what you do, you will go and do an XRD or you do an NMR. So the point is, after every step, you identify that's what you need, and then you decide what is the next analysis that you should perform. But here, agents can do everything on its own. So the point is, based on the output of step number 1, it can decide what should be the step 2. For example, imagine you're not getting a color change in step number 1. You're not going to do a UV spec. You're going to repeat the experiment, right? So that's the point. So you have a series of steps that's involved in a process, and you are not going to make decisions. Agents can make those decisions on its own and perform the task. So that's what is called, you can, if you are asked, okay, what is agentic AI, and you want to describe in 2 words, you say autonomous system that can work without human interference, right? So it's autonomous systems. Okay, it can perform either a single task or a series of tasks. What is multi-agentic AI? if different agentic AI, there are several agentic AI, they can communicate with each other and perform a task, then that is called multi-agentic AI solution. So there are different examples that's already there out there in the market, and people are using it, like Google Coding Agent, so which can write code, it can test code, and it can fix code, right? So that's the point. So then you have Uber Support Agent, it can retrieve data and resolve the riders' issues without human interference. You have GitHub Code, it can write code and suggest improvement in your code. Okay, so there are different. So now you got an idea. So what is AI? What is Gen AI? What is agentic AI? Next one. What is responsible AI? This is one area, especially if you are looking for a career opportunity. You don't want to do some coding, but I want to do something with the best use of AI in an organization. It could be even top companies like Google have a very big responsible AI group, or Meta, Microsoft, all the top companies, they have responsible AI group. So what's their goal? They want to make the safe and fair and transparent use of artificial intelligence. So what kind of things they focus on? So either whether you are using an AI model or you are doing something with a Copilot or ChatGPT, so they check for explainability. How does the model make its decision, right? Transparency. What drives the outcomes of the model? Then robustness. How well the model make its decision? How accurate and consistent are the model's decisions over time? Imagine a hospital is using Copilot or ChatGPT. You ask same question 5 different times, and each time it is giving 5 different answers. Will the hospital use that? No, right? So you imagine there is a bank and they want to use Copilot or any generative AI tool, and they ask 10 different questions, same question 10 times, and it gives 10 different answers. Then it's not going to be reliable, right? So this is what is more important. So is it reliable, right? Is it giving a consistent answers? So that's what we are focusing on. So 5 things you should focus on: explainability, transparency, robustness, accuracy, and reliability. And this is very important when you develop a research solution or if you're developing a product for an industry. So this is so critical. So 5 questions: how does a model make its decision? What drives the outcomes of the model? How well the model make its decision? How accurate and consistent are the model's decisions over time? So the other thing you ask is like, have you heard this? So suppose you are entering a query. I'm not sure if you're allowed to use in your ChatGPT or Copilot in your university. The point is, when you ask some question, when you have great ideas, you add it, these data, the whatever you're entering, whatever the queries you're adding it, so those data is being used to train the model. So the question is basically you're developing some technology within your institution. Now you're going to ask, you're just copying and pasting it in ChatGPT or Copilot. So you're just, letting the data go to the, model. It is being used to train the model. So which is risk. So what we need tools like data masking, data grounding, zero data retention, and toxicity reduction. So what is data masking? Data masking is a feature that will help. For example, you're typing a letter, right? And asking Copilot to correct the grammar for you, or rewrite it for you. So it just removes all your names, your social security numbers, or your any bank numbers, or any confidential information. It will remove all those sensitive information before it sends to the model. And when it retrieves the response from the model, it adds all those sensitive information back and then provides you with the response. So this feature is called data masking. So data masking helps to protect your sensitive data. And the next one is data grounding. Data grounding is connecting your data with the data source. So because your models like ChatGPT or Copilot, they're all trained with Facebook, Twitter. So those are not reliable source of data, but you have a reliable source of data. For example, there are models called RAG models, Retrieval Augmented Generation Model. So you give a PDF, for example, you have 5 different books, each one is 1,000 pages. You give a RAG model and you ask question, it can provide you the answers, right? So this is what connecting to a data source. This is data grounding. zero data retention. Whatever the data source you are querying, you are putting in ChatGPT or Copilot, you don't want the model provider to retain your information. So this is what is zero data retention and toxicity reduction, to make sure the responses are not harmful or so professional. So you want to make sure, so that's what is toxicity reduction. So these are some features that you should look for when you are when you're choosing a model for your company or for your institution or for your organization. So I'm going to repeat it: data masking, data grounding, zero data retention, or toxicity reduction, even when you develop a product. So these are all some of the features that you should try to include. Okay, there are other things also. Memory. Imagine sometimes you ask a question to Copilot or Chat GPT, and then it remembers next time you ask question, immediately it remembers your name, right? So you're asked to you're writing a letter, and then it automatically adds your name and then Amity University because it remembers. So how does a model store and recall those information? How does a model retain and adapt based on previous interactions and experiences? How does the model differentiate between short-term hot memory and long-term cold memory? Sometimes it remembers, sometimes it doesn't remember. So what is the difference, right? There are different kinds of memory, so you can decide like what the model should remember and the what model should not remember. There are different memory like procedural memory, episodic memory, session memory, semantic memory, hot cold memory. You can decide, okay, you can engineer when you're engineering those systems, you can engineer how the model should work. Is that making sense? Okay, so now let's see some examples. So physics, so like I give some examples just to help you understand the difference between artificial intelligence, generative AI, and agentic AI. So let me reiterate some of these. AI, you can solve any classification, regression, or forecasting problem. Generative AI, imagine just like a Copilot or Chat GPT, it can generate text, images for you. And agentic AI is either it performs autonomously perform a single task or a series of tasks, right? So that is what agentic AI. So what kind of problems you can do with this? So physics, okay, so I gave some examples. For physics or material science, I have one example. So it can analyze data and predict the material behavior for faster discovery. So let's say you have a series of independent variables and you wanted to predict how the material's behavior will be. What is a dependent variable? It could be hardness, it could be any property, any superconductivity, or if you're developing a fuel cell, you want to see energy, you want to see the voltage, right? So you want to see energy density or anything, right? Power density. So you want to measure. So you know what are all the independent weight factors, and you can make a correlation between independent factors and dependent factors. So that's what is an example for artificial intelligence. So generative AI, what you do, design novel materials. So now you want a very, in a way, you have 100 different articles, research articles, or 1,000 articles you provide. And now, based on these articles, you tell, okay, I need a material with X, Y, Z kind of properties, right? For example, I need a superconducting material with these kind of features. Now you give all the research articles. What the model will do? Model will digest all these information that you provided, and it will give you a composition, or it will give you it will give you a list of how you should how you should synthesize your compound, your desired compound. So the idea is, what is the input? You're giving some research articles or patents about that material, how it's being synthesized for 1,000 different materials. Now you're asking a new material, so you want it to be synthesized. So that is what, there are some products already there. If you say this is the product I want, this is the polymer I want, it can just help you how to synthesize that polymer, right? So that's an artificial intelligence based solution. So how do they do it? Because they already, imagine, to make 100 different recipe at home. You want to do some other recipe with XYZ taste, okay, taste, color, flavor, right? So all those things. So the point is, you give the recipe of 100 different recipe that you know to do, then now it can just help you with a new recipe. It can just do it. Okay, the next one is agentic AI. A to Z, it's just like a researcher, right? Just like a research scholar from step one to step last one. So it will do each step. It will conduct an experiment. If it is getting a result, it will do an analysis. It will get the data, and then it will go for an application, and it will draft a research article and give it to you. So number one, step one is not working. You're not getting the material is not synthesized with the desired property. It will repeat step one with different composition or different conditions. It will till it gets the final, your desired material with your desired property. It will keep on repeating it, and once it gets the material of desired property, it will go to the next step. It will conduct an analysis. If it's not getting a desired results in analysis, it will repeat it time and again, and then once it gets the desired results, and then it will draft a research article and send it to you. Right. So this is what is agentic AI. So these are the different examples I have. For example, if you have biological data, it can identify patterns, whether you are using genomic data, transcriptomic, metagenomic, epigenetic data. It can understand the patterns because these are all complex, right? The big data. So understanding the large genome sequence data is so complex, but artificial intelligence can perform it minimal time, right? It needs advanced AI or bioinformatics training. Nowadays, you don't need the skill sets, right? So because AI can help you doing those tasks. For example, if you want to design a specific protein with the desired properties, or you want a desired sequence, or you want to develop some inhibitors, you're a chemist and you want to develop some inhibitor, it could be an antagonist or agonist for a specific key disease target protein to develop a therapeutic molecule. Then you can ask generative AI to build those molecules, and you can write so which can really fit into those which can inhibit the protein, so it can help you build those structures. So I hope I gave you some idea. So you can come up with your own use cases. So for whatever the field you are in, try to build some use cases. At least try to write some 10 different use cases for AI, generative AI, and agentic AI, and how it can help your field of interest. You may be a researcher, you want to publish an article, or you want to do a patent, you want to submit a proposal, or you may be you may be an entrepreneur, you want to start a company. So take your field of interest, and then identify how you can develop an AI solution, generative AI and agentic AI solution. Write some use cases. Once you write use case, then go for whether you will do a classification, regression, and forecasting problem. And then you go further like, okay, what kind of dependent or independent variable you use if you're going to do a regression. Now let's go. So how should you use it? So now we saw something. You got some idea about what is AI. I was talking so much technical nomenclature. So now let's go a bit lighter, right? So now how do you use it? So should you use it or not? Yes, you should use it. How should you use it? So use AI to summarize your lessons, or if you have a tough concept, your ChatGPT can help you to make you understand it. It can give you some practice exercises if you are doing chemistry or physics, so it can help you solve those problems, right? So it can help you to learn better. It can help you have great idea, you can go and share it with it and check those ideas and how it's valid, so it can think smarter. But you can't allow AI to replace your thinking. That's more important. So the next one is prepare for your future, whatever the industry you are in. So whether you are in physics, chemistry, or in medicine, or whatever the industry you are in, try to explore what are the tools that's currently used in that field. For example, I shared in my previous slide, so AI is currently used to synthesize materials. Already there are many softwares that's available. If you just say you need a polymer with XYZ properties, automatically it will give you the entire protocol to synthesize those material. There are several softwares that is available, right? So that's the point. So you can identify what are those softwares or tools that's already available out there in the market, and try to get an understanding of how it works and what are the features, what are the pros and cons, and what is the gap, so that you can fill. The next one is how you should not use AI. Don't use it for copying. For example, for copying your assignment, writing an article, because writing an article is an art. You understand the problem, you write the whole story, right? You understand the problem, you see what other researchers have done, and you write what is your hypothesis. So you're writing your story. It's like a biography, right? You are feeling it and you're writing a research article. Don't just use AI to copy and paste it, because that may not be accurate, right? You're writing from your heart, right? You're not writing from your head, you're writing from your heart, right? So there's a difference. And don't skip thinking. Thinking is so critical. So the point is, don't skip thinking. Any question you have, just give it to ChatGPT. So literally you're losing your cognitive skills, right? So the next one is your skills. The third one is your university may follow some rules, right? So you may not be allowed to use, I don't know what's the policy, but depending on whatever the university allows, you can use those kind of tools, some of the AI tools. If you go to any industry, they may not be allowing you to use Copilot or Chat GPT unless you have the um, features like data masking, data grounding, and many AI tools you may not be able to use in industry. They would have blocked those. Okay, no, don't outsource your thinking. Yeah, thinking is so critical. So you can't let AI to do those things for you, right? So if you have a arithmetic, reasoning, or grammar skills, or writing skills. So imagine your as a graduate student, you have to write 5 research articles. All the 5 research articles you used artificial intelligence to write it. So literally you will have no idea of how to write an article. So that's a challenge, right? So that's the point. So don't use those are all the skills you can learn, right? So instead of that, you don't use artificial intelligence there. And last but not the least, you should remember, whatever ChatGPT or any AI tool, large language model provides, that's not true, right? They take information from different sources like Copilot, Twitter. Sorry, it takes information from Twitter, Facebook, YouTube. They are trained with a wide range of sources that's out there in the internet. It's not true, right? It's not completely true. So next one. So how it impacts your job opportunities. New careers are emerging. Industry is completely evolving. So a chemist, for example, if you see a physicist or a chemist, what they were doing before 10 years is not going to be the same in the next 5 years, 10 years down the line. So, right, it's software engineering. Let's take software engineering. AI can help you write the code. AI can do testing. AI can get requirements. So we don't need software engineers. The whole coding is done by AI today. That's number one. Let's take the situation of physics. In case of physics or chemistry, imagine there are tools. Already if I need this material, so already there are tools that can just, help you to synthesize that material. It can give you the complete protocol. There are companies that are working on robotic devices that can help in synthesizing those material. Automated labs are coming up, right? So all the quality in manufacturing units are becoming automated, and the labs, all the quality control is becoming automatic, right? It's all automated. So the point is, every area is becoming automated. So you have to understand how the landscape in your industry is changing before 5 years versus next 10 years, 20 years down the line, right? So these are the opportunities. So new careers. So AI is becoming indispensable. So whatever the field you are in, try to get those skill sets. So traditional jobs are evolving. So you take some time to understand how your industry is evolving and see how you can update your skills in artificial intelligence, so you remain so unique and indispensable in your workplace. So number 3 is employers want AI ready talent, whatever the field you are in. So you need those skill sets, right? So we were seeing in the first few slides, doctors, pilots, drivers, or whatever the field you are in, AI skills are very important because you're going to use at least 2-3 tools you'll be using on your regular basis. So don't ignore AI. So if you're avoid learning, so you'll be falling behind. So that's the reason. So whether you are going for higher education or when you're looking for career, so AI will be, it will help you to improve your opportunities, whether getting jobs or getting scholarship or leadership roles. Next one, how to build your AI skills as a student. You have a BS student or you're a master's student. So your university may have some AI clubs or workshop. Try to do some hands-on skills. Try to get some coding skills, or if you're not interested in coding, you focus on ethical use of AI, which means the responsible AI use, which I was talking about. Or you build your own projects. You can build some apps in physics related to physics, chemistry, or related to your field. You participate in presentation, go and present in conferences, workshops, right, or symposiums, and then you stay updated, you follow, there are several news, right, article newsletters that's available in LinkedIn, so you can enroll for those newsletters, and then you can attend the workshops organized by professional societies. Different professional societies are organizing events, you can go and attend. So one thing I want to tell you is, you try to get the coding skills. If you're in your bachelor's, you try to get those coding skills, but not always coding skills are important, right? For example, let me give you an example. If you're doing a data science, so for example, if you're working on data challenges, then you will be focusing on data quality issues, integration challenges, handling large volume of data, managing unstructured data. This becomes so technical. But you're saying, oh no, I'm not interested in being technical, but I like management, like project management. So you have data management, where you focus on data governance, data architecture, data storage, data security, data analytics, data lifecycle management. That's bit not too technical. No, you are saying even that level of technical is not, I'm not interested. So I'm more into a policy person. Then you say data governance policies, data architecture standards, data stewardship guidelines, data architecture framework, metadata management plan, compliance reports. So these kind of things. So all these are very important, especially when you have a background in science plus artificial intelligence. When you go to industry and developing those compliance report, so that's going to be really very helpful. Okay, so I'll give you some examples of what kind of skills you can develop. So skills is the first one. Let's see, technical. So you get the data skills. You're very good in math. You're good in statistics, and you can learn Python and SQL. SQL is very simple, and Python also, everybody know Python these days. So if you learn these basic skill sets, so now as science graduates, this gives you a lot of opportunities. You have a background in science. You also are good in statistics and experimental design. So what kind of jobs opportunities can you get? So you can become a data analyst. See, companies like Meta, Amazon, Google, Apple, or Microsoft, they have features like, okay, the roles like data analyst, where you analyze the data set, right, and build dashboards. And you can become a business analyst. You convert these data into business decisions, and you can become a product analyst. You can do, right, user behavior. So all these, what I mean to say is, these are all in your domain, whether your domain is physics, chemistry, or biology. So in your domain, so you become a specialist in those specific industry or specific areas. Okay, next one. Now you are super technical. I will learn a lot of hard coding, and then you learn machine learning or AI foundations. You get all the, see, this is what I was talking about. You learn regression, classification. You are strong. You know to build problem, you build models. You know how to validate the models, how you know how to ensure data privacy and security for the organization. So you have a very strong math background. You're good in calculus. So the point is, what kind of jobs you can get. See, companies like Google, Meta, Amazon, Nvidia, they have roles like ML engineers. You can become a data scientist if you're good in statistical modeling, experiments, prediction insights. And you have applied scientist role, where you can apply ML for real world problems. That's what we were talking about today. And the next one is AI research assistant roles. You support research teams and run experiments and analyze results, right? So for example, IBM was working on IBM Watson. So all these companies, right? Amazon, Amazon, Google, Microsoft, they're all doing, advanced AI based research in physics, chemistry, or even biology, right? Even Apple is doing a lot of wearable devices. So if you're too technical, then this is good opportunity. The third one is more into it's not technical, it's more into research skills. Okay. Sorry about this. Okay, yeah. So if you're good in designing experiment, testing hypothesis, and iteration based, so yeah, you get these kind of roles. So Meta, Google, Amazon, and Netflix, they have A/B testing analyst role. You have applied scientist role in okay, and then you become a user research assistant, or you can become a research scientist, where you'll be exploring new ideas and designing experiments and validating the outcomes. Okay, so yeah. So let's go into higher education in AI. So now you are doing a bachelor's or a master's degree, or if you are a bachelor's, you'll be looking for a master's MS program, or if you are a master's student, then you'll be looking for a PhD program, right? So, or the other one is even if you have a 4 years bachelor's program in India, okay, if you are doing a 4 years bachelor's program, then you can get a direct PhD admission also in US. So that's also a possibility, right? So you can get direct. So what you can do is either you can do a MS program or a PhD program. Two things you're passionate about AI. So there are two ways you can do. You can directly go to their AI program or a computer science program and join the computer science program or AI program. Or the second opportunity is every department in every discipline, these universities have AI as a feature, right? So whatever the research that you're going to do or master's program you're going to do, so they will have AI in it. So that's not, so you don't have to focus on taking an exclusive AI based program. It's up to you, but there are two different routes you can do. So after a BSc or MSc, you can go and take a master's program in artificial intelligence, data science, or computer science. Or there is other route, you go and take your own field of interest, either it is in physics, chemistry, or biology, or any sciences or engineering, and then AI will be a part of it. So you don't have to worry like, oh no, I have to go and take artificial intelligence. It is not needed. Whatever the PhD, same is with your PhD program. You're interested in some research area, so you don't have to exclusively go and do in AI. So whatever the field you're passionate about, go and take that, but do AI as one of the application, right? So AI is one of the feature, and it is used everywhere, right? Most of the research labs, most of the universities are doing AI is one of their prime focus area. So AI will be a part of it. So whether you can, so you can do it in two ways. Either you can go and exclusively learn, take an AI based program, or you can choose the program of your interest and take AI as a part of it. Okay, so how do you choose the right university? Suppose you're going for US, right? So let me first talk what do you need for getting an admission. The point is, if you are planning after your bachelor's, if you want to take, or a master's, you want to take a MS degree, they look for two entrance exams you have to take. One is GRE and the other one is TOEFL. Some universities may prefer IELTS instead of TOEFL, but most universities need only GRE and TOEFL. So always, most of them, they prefer TOEFL. Okay, IELTS is okay, but it's not generally preferred. So GRE and TOEFL are must. That's number one. So you have to take it. So when should you take it? Suppose you are in your BSc program. So take it in your first year, prepare from your first year so that you can take it at the end of your second year. So you can use it in your early first. Third year, you will start submitting your application and the process takes at least 6 months. So when you get your admission, it takes, when you finish your bachelor's, you get your admission. So that's take as early as possible. But your GRE and TOEFL marks will be valid only for a limited time, and generally universities prefer something like you should have taken it before 6 months or 1 year. So take it when you're in your third year, early third year, or at the end of your second year. Okay, so if you're a master's student, again, you take it in your first year, you take your GRE or your TOEFL, and then you in your second year you can take the prepare in your first year, take it in your early second year at the end of your first year, and then you can apply, submit your applications. So you get complete assistantship when you go for a PhD program, right? So you can get it. So that's how it works. So after your master's, you can go for your PhD program. If your bachelor's is a 4 years degree, then you can do a PhD program directly, and from day one you'll get your assistantship. Okay, so now how do you choose the university? So see what programs you're interested in, especially when you're doing in AI or some specialized areas. For example, you want to do some nuclear physics, you are wanted to do something space research, you want to do something like, any specialized areas, then you see whether that university is having those unique programs. Do they partner with those national labs? So for example, you want to do some space research, then see whether, are they partnering with NASA? Are they partnering with USGS, United States Geological Survey, right? USGS, or whether they are partnering with Jet Propulsion, NASA Jet Propulsion Laboratory, right? Or whatever the lab, okay? Or you are NREL, National Renewable Energy Laboratory. It's a Department of Energy. So do they have those programs partnered with those agencies? So that's something you will be looking for. Second one is if you are a PhD student, no worries at all. You're not going to pay any fee. There may be fee, but you get scholarship. Basically, you get assistantship. So if not, then you have to see whether you have the affordable fee and what is their financial aid. Most universities provide financial aid and scholarship. You have to check for what scholarship. The location is very important and support. Okay, which part of US you want to do? You want to do in you want to do in the Bay Area, so California or Bay Area where your job opportunities are abundant. You want to go to Silicon Valley, you want to be an entrepreneur, something like that. So if you are in a tech industry, then Silicon Valley is good. Or Seattle is a good area for Silicon Valley. If you want to do pharmaceutical, then you go for Boston is a great area. Or St. Louis is one area, is for life sciences industry. So depending on the industry you choose, okay, what is the location and which state you want to choose, right? So whether you're going to be in the Bay Area, you're going to be in Seattle, you're going to be in St. Louis, you're going to be in the DC area, or you are going to go to something like Colorado or Minneapolis. If you are more in the chemistry side of it, you want medical device industry is they're all in Minneapolis or Minnesota. So you choose the location. Location is very critical. That's where you go for internship opportunities, right? So that's number one. The quality of engineer education. Check for the ranking of those universities. So student reviews. Talk to your students, other students who studied in those universities. What are the job opportunities? What are the research opportunities? What research infrastructure they have? And more importantly, all these are important, but what really matters is great teachers matters, right? So if your teacher is great, they can shape your life, right? So that's more important. So you have to check those things. So whether the teachers, whether the experience, whether the faculty have experienced faculty, you have to talk to those students and see the environment there. Next one, myths about choosing universities. So generally students think Ivy League means better university, right? So the point is, oh, I want to go only to Harvard, Princeton, or Stanford, right? So Ivy League, there are 8 universities. It's great if you go to Ivy League, that's good, but it's not that, okay, you have to go only to those universities. There are other universities as well. There are great state universities. Recent finding, they found that many CEOs are from state universities are not from Ivy Leagues. So Ivy Leagues are 8 high top rank universities, like for example, Harvard, Princeton is an Ivy League, Yale University is an Ivy League, Brown University, Columbia University. These are all Ivy League universities, right? So if you get into Ivy League universities, that's great. Otherwise, there are no worries. There are several state universities where you can apply. So the other one is, okay, the other myth you have is, oh, my cousin studied there, my uncle studied there, my aunt studied there. No, it may be good for your aunt because your aunt studied before 30 years. So don't have that myth. So you see what is good for you. The next one is the name of the universities, the brand. Don't go with the brand also. So it is about, especially when you come to science, it is about what is the kind of problem you're going to solve. Do they have the infrastructure? Do they have renowned leaders in the field, right? What kind of publications they have made? So those are all the things that's more important. So you are going to solve one specific problem in your master's or your PhD, which will transform your life. And do you have a mentor in that university? That's it. Okay, AI opportunities. So top universities. So yeah, I was talking about the BS, MS. Okay, yeah. So what are the programs? So this is something I can talk about. Okay, so top universities I was talking about. So either you can go to you can go to Ivy Leagues or other top schools are also there. UC Berkeley is one great school you can try. And the programs is you can do MS program. And one good thing is whether you are in physics, chemistry, or math or biology, you can choose any master's program. Even you want to do a computer science, you want to do a master's in computer science, yes, those universities are very flexible. You can do a master's in computer science. You can completely move from one field to other. For example, you are very good in technically, you are super strong in your science and artificial intelligence, and you want to become a patent attorney. Yes, that's possible. So what you do, you could do a program called JD. We call it Doctor of Juris, just like a PhD. It is a doctorate in law, Doctor of Juris. So it's a program. It's a 3 years to 5 years program. Once you finish that program, you can practice as a lawyer. So I'll be discussing about this after a few slides. So I'm repeating it. You are good in your discipline, very strong. You have a very strong technical background in your field and artificial intelligence or any other emerging areas, and you want to become a patent attorney, so then that's a great opportunity. So then once you've become a patent attorney, you can start your own or your own company. You can provide consulting to large corporation, industry, startups, government. You can help, right? Or you can directly work for large corporation as a counsel, or you can work for the government as a lawyer, right? So those are all opportunities you have. So flexible program. What I want to say is you don't have to confine, like, okay, if I are doing a bachelor's in physics, you want to do a master's in physics. Not necessarily. You can go to any discipline. They are very flexible about it. Okay. So scholarship and internship. So most universities offer financial aid. Basically, financial aid is so they do a blind admission process, meaning that they don't see your financial status when they provide your admission. So it's a need blind fellowship process. So basically, they don't see your financial status, so they provide you financial aid. So after your master's or your PhD program, so there are opportunities. Either you go to industry or you become a professor, or you can, start your own business. Next one. So how do you prepare? For example, if you prepared for Harvard, Princeton, or Stanford, so what do they look for? They don't just look for your CGPA is important. That's very important. They have something, you convert this into a 4 GPA grade, a scale, right? So when you convert it, always if you have a good GPA, that's very important. And the second one is your GRE TOEFL score. That's also important. But more than that, they look for your leadership skill. They want to know who you are and what you want to do. They don't want to know what you've accomplished. They want to know what you want to do. What is your story? That's something they are more interested in. So you show what are the kind of leadership activities you have taken, what kind of activities, what kind of impacts you have created outside academia, right? So what kind of activities you have done, what is your expertise. So those kind of, so craft some compelling essays that reflects what kind of values you do. What kind of, do you do some co-curricular work? Are you good in extracurricular? Do you do some social service? And what impact you created? So that's more important. The word impact is more important. Okay, what is the impact that you created? So the next one is advantage, as I was telling you. So it's a global prestige, and you have network with you when you study in top universities like Harvard, Princeton, or Stanford, or any top universities. You have an opportunity to network with, right, your allied faculty, research, and alumni across business science and industry. And your graduates, generally you go for roles in tech industry. You go to Meta, you go to Apple, you go to Amazon, Netflix, right? So you go to top companies. Second one, people go for consulting. When you go to consulting, we call it big three. Do you know what is big three stands for? McKinsey, BCG, and Bain. BCG is Boston Consulting Group, or Bain. Generally, universities from these top universities go as consultants to these top three companies like McKinsey, BCG, and Bain. So generally, people who work in these consulting firms become CEOs. For example, if you take Sundar Pichai, he is from BCG. If you take Indra Nooyi, she is from BCG, right? She is from BCG. So generally, people work in these consulting firms, so they become CEOs. So, or you do medicine or academia, whatever the industry you are. So need blind, I was talking about the need blind policy. So, generally we think, oh, it's so expensive. No, Harvard and Princeton don't consider financial status for admission decision. So you get 100%, okay, financial need, right? They cover. So that's what is called a need blind policy. So it's a financial status is not a limitation. Okay, so when should you start preparing? So this is what is, for example, if you are a BS program, start preparing early. In your second year, prepare for your GRE and TOEFL. End of your second year, you should take the exam. I would say prepare when you're first year. and then take mock exam, as many mock exams as much as possible, and then take your exam at the end of your second year, and then start applying in your third year. So then you can get your admission for your master's program. Okay. So the next one is, okay, what scholarship? Okay, no loans, or so I was talking about the need blind grants. So these universities offer, okay. The next one is, okay. So MS, so this is what I was talking about. So you do, oh, there is another one, but this is generally if you are in a biology background. I don't know if there are students in biology background in this team, in the session, but anyway, if you have a bachelor, so this is how it works in MD. For example, you may be thinking, I'm doing a BSc in biology or chemistry or anything, any discipline, even it can be economics, you can do commerce, or you may be doing archaeology, and you want to become, you think, oh, this is not something I want to learn. I want to become a doctor. I want to do an MD. Is it possible? Yes, it is possible. So how does it work? MD in MBBS, it is called, MBBS is in MD in US is an equivalent to MBBS in India. I'm repeating it. MD in India is different. Okay, MD is after MBBS, you do MD and MS in India. But in US, MD is equivalent to MBBS in India. So how do you get an admission to MD? You need a bachelor's degree. The bachelor's degree can be in any discipline. You can do it in science, you can do it in math, you can do it in archaeology, economics, or commerce. After doing your bachelor's degree, you write an exam called MCAT exam. So you may have a question. Okay, I go and I do a BSc in chemistry, and then I do join MBBS, but I don't have a background in biology. How can it work? That's a good question. So how it works is they look for some basic courses. They ask you to take some basic prerequisite courses like microbiology, cell biology, physiology, biochemistry. There are maybe 4 or 5 courses that you should take, the prerequisite courses, and then you can join an MD program. So you have a BS, and then if you want to do an MD, yes, that is possible, right? Irrespective of whatever the discipline you are in. So I'm repeating it. If you missed the boat to join an MBBS and you want to do an MD, yes, that is possible. After your after your master's degree, you can go and do an MD program, irrespective of whatever the discipline you are in. You can be in science, math, commerce. What exam do you need? It is MCAT. MCAT is the exam. So do you need any prerequisite? Yes, there are prerequisites. You may be expected to take some courses like biochemistry, physiology, anatomy, microbiology, cell biology, and few biology courses. And okay, what other options? You are doing something in physics, you are doing in artificial intelligence, and you want to do something in other areas of healthcare. Yeah, you can do some biomedical engineering programs, public health programs, neuroscience program. Interface of AI and neuroscience is really booming like anything. Most of you might be familiar about Elon Musk Neuralink, right? Company, right? And other health related programs. So these are the top tier. So if you want AI, you improved your skills in AI and you wanted to go in one, focus on tech companies. If you want to go to industry, go focus on tech companies like Manji companies. We call it Manji. Meta, Amazon, Netflix, right? Amazon, Apple, Netflix, and Google, right? So these are all the top tech companies. You can go and do research. You can go to consulting. I was talking about the big three. What is big three stands for? It is McKinsey, BCG. BCG stands for Boston Consulting Group. And the third one is Bain Consulting. These are all the big three consulting. So you can try to go to consulting. They need AI-based experts. And you can go to healthcare industry. Healthcare industry needs a lot of AI-based professionals. So yeah, if you do, okay, what is the advantage of studying in those in top US universities? Some of the advantages, if you study in any, not only US, any industry, if you study, your alumni, okay, often okay, you have good contacts with alumni, so you will be okay, they will be have advanced degrees in leadership worldwide. So you can, if you have a science background, you can become a research analyst, you can become R&D, you can do R&D. If you can become, even you can become, because nowadays you don't need any coding skills. So the point is, the good thing is, even if you have a physics, chemistry, or math background, you want to become a software engineer, it is very much possible, right? Because all the code is written by, whether you want to become a front-end developer, back-end developer, you want to become an analyst, you want to become a or you want to become a tester, everything, it is done by AI. So you don't really need to have coding skills, but try to get at least the basic coding skills in Python or R. These are all very important, right? So this is something, it will give you some idea. So I'll talk about this law JD program I was talking about. The JD stands for Doctor of Juris. If you are doing your physics, your bachelor's or master's or a PhD in physics or chemistry or biology, you have a very good background in technical background, artificial intelligence, or any emerging technologies, and you want to become a lawyer, a patent attorney or a patent attorney, then you can do a JD program. I will talk about it in depth. So thank you so much. So my deep appreciation goes to Ayana for taking a lot of for her hard work and a lot of time and efforts. I also appreciate Professor Preeti and Professor Seema for their initiative, and thank you so much. So before, let me give you the JD program. Let me share this JD program with you guys,
So
so
I
you get
guess
an
that
idea.
this piece, last slide was made by AI, right?
Oh no, no, not really.
Hmm.
No. Oh, okay, let me start this. Okay.
There is no voice.
Oh, no voice? Okay, okay, sure. Oops. Okay, sorry. Okay,
Hello.
let me. Yeah, can you hear me? Can you hear me?
I can hear you, but your video's voice was not there.
Okay, perfect. I will do that. Mm, okay, let me stop share and then again share it. Hopefully that should work. Okay, enter your screen. There is audio. Okay, share sound. Perfect. All right. Now can you hear it? Now can you
Audible?
hear the audio?
See you and we can see your voice. We can hear your voice, but I mean, video is not there.
চ্যাটে কোশ্চেন করতে পারছো না?
Okay, I will repeat it. I will do it again. No worries. Yeah. Let me do it again.
Hello.
Yes. Yeah.
Yeah, yeah. Thank you,
Sharing it.
Krishna. Thank you for your informative and as well as inspiring lecture. There are a few questions. Just
Yeah.
give us a few more minutes.
Yeah, sure. No,
There
no
are some
worries. No.
students asking.
Yeah, sure. I will, in the meantime, I'll just
More
share
than
this.
1.3 million out of more than 1.
Can you hear the audio now?
Yes,
Hello?
yes.
Yes? Okay, perfect.
Yeah,
Wonderful.
yeah.
Okay,
Out of more than 1.3 million lawyers in the
Audio.
United States, only a very small number are from international backgrounds.
oh, audio is not, you're not getting the audio?
Sir, have you selected
Can you hear it?
Sir,
Yes,
Yeah,
we
yeah.
can hear. We can hear,
It
Dr.
is
have you
playing.
selected option, share sound option while sharing?
Out of more than 1.3 million lawyers in the United States, only a very small number are from international backgrounds. This shows how competitive it is to enter the U.S. legal profession. Gov2 Partner helps students with admission support for top JD programs in universities like Harvard, Stanford, and other leading law schools. For international students, the main challenges are understanding the U.S. legal system, qualifying for the bar exam, and planning a long-term career. A Juris Doctor, or JD, is the main degree required to practice law in the U.S. It gives opportunities in government service, corporate legal departments, and private practice. Salaries are very attractive per year. Government lawyers usually earn $70,000, $120,000. In-house corporate counsel earn around $120,000, $180,000, and top law firm associates start at $215,000 or more. Fields like intellectual property, compliance, and healthcare law are also growing fast. Doing a JD in the US means world-class training, global recognition, and excellent career options. If you are interested, please contact us at
Awesome. So this is about JD programs. So yeah, so I hope you got some idea. JD program. Yeah. Awesome.
Hello.
Yes, please. Yes, Aina, please.
Hello.
Yes, Aina.
There is some question from the student.
Yeah,
Yeah, please ask.
yeah.
Good evening, sir. So my
Good
question is,
evening.
how do current AI detection system identifies that piece of text was generated by AI? And what are the fundamental limitations to making those determinations? Because sometimes AI detectors flag real human text as AI generated.
Oh, okay. So how do you differentiate? Sorry, come again. I missed the question. So how do you differentiate between AI generated text versus human generated text? Is that right? Is that your question? Detection
Yes.
system identifies the
Yes,
piece
actually,
generated by
she is asking that how the AI can differentiate between the AI generated text and the normal text, because sometimes it is misbehaving, and originally written text are taken as a AI generated text. So what is the algorithm or limitations? She is asking.
Yes, that is true. That is true.
Uh,
That's very common, and there are several tools people are using. I don't know what exactly is the algorithm people use it for this, but there are different tools that is available out there in the market, and those tools can really help in accurately predicting that. But that's a risk, actually. How can you mimic? You can ask ChatGPT to write like a human, so it's going to write like a human, which those tools cannot detect.
Yeah, thanks. And I think the models are also getting refined day by day. Like, AI is based on basically it is comparison, right? So those models are getting refined day by day. So that was a good talk. And two, three things maybe I just want to share. Like, one thing is that, if you're a science graduate, you get an additional 2.5 years of OPD. So that maybe the student should be aware of. Then, there are no visa issues. Like if you go on an F1 and then you automatically get an 1 year of OPD, right? Optional work practical
Yes.
training. And then if you're a science graduate, you get 1.5 years more. So like 2.5 years, you can
Exactly.
actually continue without changing your visa status. And another thing that, I think the students should be aware of is there is an organization called USCFI, United States Education Foundation in India. That is basically a joint collaboration between the US government and the Indian government. So there are centers in Delhi, Calcutta, Mumbai, and I believe either Bangalore or Chennai. So, I mean, the students who are attending and who are thinking of going abroad, they can actually go to this USCFI. It is behind the US ambassador's house in India in Haley Road, and it is pretty inexpensive. Like, it is not a private organization, it's sort of an NGO. So it is funded by the US government. So, if the students are interested, they can go to USCFI. There is a library. I mean, I went to USFI and studied. I did my master's and PhD
Oh,
from the
nice.
US. And so this is a very
Mm.
invaluable resource. So there is a library and there is a counselor who will actually, check your SOPs. Okay, and then counsel you on things and what to apply. And routinely, the US universities themselves come and advertise, the different programs. So
Yeah.
that is what I wanted to say. So thank you. It was an excellent talk, sir. Thanks.
Oh no, such a pleasure connecting with you. And this is really a good point. OPT is really a good one. Yep, especially for science graduates. Yes.
Thank you. Thank you for
Thank you,
your
Aina.
words. And let's stop here. And you are
Yeah.
awake at late at night or
Oh
wee
no,
hours
no,
of
it's
morning,
very
I should
common.
say. So we'll be meeting tomorrow for the
Yeah,
neuroplasticity
sure.
sessions.
Dr. Aina,
Perfect.
Dr. Aina.
Yeah.
Before closing this meeting, I request all faculty members and students present here to open their cameras so that we can have a good photograph for report. All are requested to open their cameras, please.
Control print screen.
Control P नहीं है ना.
Control print screen.
And
Print
Nirmal
screen.
sir, you also open your camera. Don't join Dr. Aina.
So where are we?
Everyone, please do it
यहाँ
quickly.
पे तो
इतना time नहीं लगना
perfect
चाहिए.
है.
Akshan
Okay,
and
hi,
Jia,
हम लोग
Bansal,
हैं.
Payal
तो-
Yadav, everyone. Sachin
control
Kumar,
print
Dr.
screen.
Abhilash.
Control print screen है ना?
The time क्यों लेते? Please
Because
open your
it's important
camera,
here.
Payal Yadav. Ikshita, don't take time, beta. Immediately open it.
नहीं ये नहीं.
Excellent.
Aina ma'am, आप बोलो शायद तब सुना
हाँ,
on करें. Priti ma'am, you tell.
Yes, dear participants,
slide.
kindly switch on your cameras fast.
Control
Can
wait.
you-
Here we go. ठीक है. Yeah, ले लिया. Done.
Dr. Abhilash, please open.
Control
Because
print
it
screen.
looks so bad when others are closed. And Dr. Rita, everyone. If everyone is open, then it will look good.
Where is he located?
South Dakota.
South Dakota. Wow.
Yeah. No,
So
I'm
you're in
in
South
Washington,
Dakota,
DC
sir?
now. Yeah. No, I moved to Washington, DC, sir. Yeah.
Washington,
I moved to
DC or the
Washington,
Washington
DC.
State?
Yeah. Mhm.
State.
Yeah,
Ikshita,
Washington.
Mayank,
No,
why you
Washington,
are not
DC.
opening, Priti ma'am?
Huh?
Maryland. I'm in Maryland. Yeah. Mhm.
Maryland. Okay.
Yeah,
Maryland.
yes.
So the East Coast Washington, not the West Coast one.
Dr.
Okay.
Aina,
Yeah, exactly.
Hello.
please tell all participants to open camera.
Hello.
Yeah.
Please open.
Please open the cameras.
Please open the cameras. All the participants, please open the cameras.
Students and faculty members who have joined online, kindly switch
I
on their
can see
cameras,
most of the
please.
students. Only
Hello.
Dr.
Please
Rita
open
and
the
Dr.
cameras.
Abhilash, they have not. Dr. Rajushi, maybe they are not here.
Mayank, Ishita. Yeah, please. I think I'll take one more. Control print screen. Yeah. Okay, ma'am. Taken.
Okay. So others are not opening. Okay, thank you.
Such a pleasure connecting. Thank you so much. Yeah.
Thank you so much, sir. Thank you so much.
Thank you,
Thanks for
Professor.
your
Yeah.
wonderful talk.
Yes, I
Oh,
do.
thank you
Every
so much.
workshop
It's
is
such a
2 days
pleasure
workshop.
connecting with you all.
Tomorrow is also a session, right?
Yeah, tomorrow is also a session. Yes, ma'am. Mhm.
So I was, a bit of thing was in my mind that we'll be learning some AI tool during this session, but maybe it was
Oh, okay.
introductory.
Yeah. The idea is it's all about once you know how the regression works, that's simple. That's it. Yeah. You can build those models. Yeah.
Dr. Ratan, I'm looking forward for your session tomorrow.
Oh,
was
such a pleasure connecting with you, Professor Preeti. Thank you so
Same
much.
here,
Yeah.
same here.
Thank you. Thank you, students.
Thank you.
Thank you, students.
Thank you. So can I leave,
Thank you.
Dr. Aina?
Thank you, ma'am.
Okay, can I leave now?
Joanna, bye.
Yeah, sure. Thank you.
Thank you. Bye. Bye.